Hey everybody, welcome to Bertrand Math. Today we are graphing absolute value functions, part 1. This is attached to homework 73. So I'll give you a second, get yourselves together, and let's get ready to go. Okay, let's just dive right into it. Hey everybody. All right, so let's just remember, right, we're going to graph absolute value functions. We've talked about absolute value before, right? That absolute value only cares about that distance from 0, right? So if you have a -3, the absolute value of -3 is 3. The absolute value of 3 is 3. So imagine if we wanted to come up with, right, here's our input of x's, and we wanted to graph this, but you also, you know I like to start with a table of values. So before we graph it, let's come up with a table of values. I just picked these because they are easy ones to start out with, and I wanted to showcase some negative ones and some positive ones. So I kept it really simple. And anytime you're graphing these functions, everyone, keep your numbers, keep your inputs, if you will, your x's, really simple, because we just want to sketch. We just want to know what's happening. So when I input -3, I get 3, 2, 1, 0, 1, 2, and 3. Okay, that makes sense. So I'm gonna convert over here to my trusty whiteboard here, and right, I'm gonna put that in here. 3, 2, 1, 0, 1, 2, 3, and we are graphing f of x as the absolute value. Now remember, we used to write it like this. Now you're used to seeing a lot of equations like this, remember, right, where we're turning them into functions. So we started, remember, earlier this year in algebra, we're talking about changing things from y equals, right, to f of x equals. We still treat it the same way. So I'm going to write it like this, and we're going to graph it the same way we've always graphed it. I just want to put that reminder in there. So if I were to graph this, right, I start at 0, 0, 1, 1, 2, 2, 3, 3, and I see that, I'm going to erase this real quick. My graph of absolute value of x looks like something like this, right? Something like that. This absolute value. That makes sense, right? And you can see -3, 2, 3, 2 is coming here, and then it has that vertex at 0, 0. Okay. Now, consider I wanted you to graph this. Now, I'm going to switch back over, but take a look, right? Take a look at where this -2 is, right? You see this -2 is inside the absolute value function. Okay, so if I were to switch, just in case, let's say I didn't know how to graph that. Let's say you were like, I don't know what that is. Oh, and let me be clear. Let me be more clear. I would write this as something different. I'm going to go ahead and write this as g of x. What this means is I already have a function f of x here, right? This is f of x here. Now I want to draw a different function, so I'm just giving it a different letter, right? To not be confusing. We don't want to be confusing. So I'm just calling this g of x. So let's say I wanted to consider g of x, which is the absolute value of x minus 2. So if we know g of x is the absolute value of x minus 2, well, let's do some math, y'all. I'm going to put g of x here. I put in 0. 0 minus 2 is -2. The absolute value of -2 is 2. Right? You're not putting in this. You're putting in these. -1, that's going to give me a 3. That's going to give me a 4. That's going to give me a 5. Think about your math. I'm going to get a 1 here. 0 here. And, yeah. And a 1. Now, I'm going back over to my graph. Now, if I just kind of like cheat a little bit, essentially what's happening is that if you were to graph this, the graph should look something like this. Now, it might be tough. I'm going to go with a different color so you can really see it stand out here. I'm going to do this, right? G of X. I'm going to do it in a red. I really want it to stand out so you can see what's happening. So if I switch over to red here, boom, 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 boom. It's not the best, but hey. Now, essentially, look at what happened. What did you notice? You should have noticed same type of graph, but what happened? It shifted. This graph shifted to the right 2. Interesting. Our original f of x graph starts here, but when I put in an x minus 2, it shifted to the right 2. So what if I were to give you, right? Consider this. What if I had written this graph plus 2? What would have happened to the graph instead? I'll give you a second. It shifts to the left. Okay. So we can determine when there's a number plus or minus, when it's inside of the absolute value symbol, it's going to shift the graph either right or left, depending on that. Because you would, if you were to try it out, and I'll sketch it out for you if you want to try that on your own, you would see something like this. Right? I want you to have that image. If you're looking at the video right now and you're taking a pause to kind of look at it, that's what happens when you have a value that's inside of the absolute value symbol, right? Absolute, right? Remember our original, just the absolute value of x is this in the black, but depending on the plus or minus on the inside of the absolute value, it's going to shift it left to right. So, chickadees, my question then becomes, what if I came up, just one more, hold on, we almost there. If I came up with one more type, what if I said, okay, I wanted something that looked like that, where now, check out the location. Look at the original. Look at what we were working with, right? We were talking about this one. We also were talking about, even though I didn't graph each one, right? We talked about both of these types. Okay. So now, we're going to talk about both of those types. And as I'm like setting this whole thing up, you have probably already figured out what's going to happen. Remember, when the value was inside the absolute value function, it shifted the graph. I've shifted the graph either left or right, depending on the symbol. Oh my God, I can't talk today. Now, check out the location. Now we have a value. We have something happening outside of the absolute value symbol. So if the inside shifts left and right, then guess what the outside's going to do, people? Up or down. But just. Let's say you want to graph this one. Let's say we graph this top one here, the plus 2. Okay, so that means I'm going to get a 2. If I put in 0, I get 2. This is 3. This is going to give me 4. And this is going to give me 5. This is going to give me, if I put in 1, I'm going to get 3. I'm going to get 4. I'm going to get 5. Now, I'm going to cheat one more time. See, right? If I can do this. Now, let's say, right, to make this even more crazier, but it should make sense. I think the oranges show up pretty well. Orange is light. I wonder if the green might work for me. You can kind of see where I'm going with the green. So we're going to lean into the green. So let's say I wanted to graph this. H of X is the absolute value plus 2. Let's say I want to do that, plus 2. Actually, I'm going to go ahead for, because it's going to be a little neater if I do minus. So, and I'm glad that I did that. When I did plus 2, if you got it right, it would take this graph and put it up here. But I'm going to go ahead and do minus 2. So I'm going to cover those results because that was from minus 2. And you should have guessed, right, if I do this, that my black absolute value original graph should come down to, so it looks something like that, even though it's kind of messy, but you get where I'm going, right? It comes down that way. So to recap, I'm going to give you a second to kind of take all that in, right? And I want you to think about something. I'm going to erase, and I want you to think about all the stuff that we've covered. Okay. Let's just try a random one. Almost done. Here's a sketch. Let's say I wanted you to sketch, excuse me, the function absolute value of x plus 3 minus 1. Without even, and this is my last point, without even doing the whole, you could do this part over here, you can do this, right? Tell me how it's shifting. Go with me, right? When it's on the inside, so am I shifting? It's plus 3. So am I going to shift to the right 3 or to the left 3? I'm going to give you a second. In order to figure that out, what value does x have to equal in order for this to be 0? -3. So that means the shift is going to go this way. And with this number, right, that's -1, am I going to shift up or down? I'm going to shift down 1. So my shift of my graph, shift left 3 and down 1. So your graph sketch would look something like that. Okay? Give it a shot. There's a few graphs that I want you to try. This is pretty much the most complicated I want you to try today, but let's just start on it, right? We're just starting with graphing absolute functions. We're going to give it a few days. It won't be bad at all. But there you go, in a nutshell. Remember, this is attached to homework 73, and I will see you in class soon. Remember, be well and go forth unafraid.